To show that the square root of 1 minus cosine alpha over 1 plus cosine alpha equals sine alpha over 1 plus cosine alpha, I want to get rid of the root on the left-hand side. So what I want to do is, let's see if I can multiply by 1 plus cosine, and then see what happens when we get squared, because remember, if we square something or square root something that's squared, we can get rid of the square root. So let's try that. In the denominator, I wind up having 1 plus cosine squared of theta. That's good. And then in the numerator, I wind up having the sum and difference, which is 1 minus cosine squared of alpha. Well, I know the Pythagorean identity that says the sine squared of alpha plus the cosine squared of alpha equals 1. Then sine squared of alpha equals 1 minus cosine squared of alpha, which is the numerator. So I can replace the numerator with sine squared of alpha, and I have 1 plus the cosine of alpha squared in the denominator, which actually looks like what we want. If you square root the left-hand side, the square root of sine squared is sine. The square root of 1 plus cosine of alpha squared is just 1 plus cosine alpha, which is what we wanted. Okay, if sine of alpha equals negative 5 over 13, and alpha is between 3 pi over 2 and 2 pi, find the exact values of the expression. So you know what we're going to do. We're definitely going to draw this out. If alpha is between 3 pi over 2 and 2 pi, that's in the fourth quadrant. Sine is opposite over hypotenuse. Hopefully you recognize this is a Pythagorean triple, and that value for x is 12. And so we're looking for the sine of alpha over 2, which is equal to plus or minus the square root of 1 minus the cosine of alpha over 2. We also want to find the cosine of alpha over 2, which is equal to plus or minus the square root of 1 plus cosine of alpha over 2. And we want the tangent of alpha over 2, which is equal to plus or minus the square root of 1 minus the cosine of alpha over 1 plus the cosine of alpha. And so for each of these, we need to find the cosine. And the cosine is 12 over 13. The biggest thing we need to figure out is what's the sine of where the half angle lives. So taking half of this angle, if it was in the fourth quadrant and we go halfway back, we are going to be talking about in the third quadrant. Think about this. We've got 3 pi over 2 is less than alpha is less than 2 pi. And we cut all of those in half to get the half angle. Then alpha over 2 is going to be between pi and 3 pi over 4, which is in here. And so in the second quadrant, our x is negative, but our y is positive. And so our cosine is going to be negative, our sine is going to be positive, and our tangent is going to be negative. The sine of alpha over 2 is then equal to 1 minus 12 over 13 divided by 2, which is 1/13 divided by 2, or 1 over 26 square rooted. That's the same thing as the square root of 1 over square root of 26, which is 1 over root 26, which you know we rationalize, and we get root 26 over 26 for the sine of alpha over 2. The cosine of alpha over 2 is equal to the negative square root of 1 plus 12 over 13 divided by 2. That's equal to the negative square root of 13 plus 12 over 13 divided by 2, which is the negative square root of 25 over 26. That's negative root 25 over root 26, or negative 5 over root 26, which we rationalize. And we get negative 5 root 26 over 26 for the cosine of alpha over 2. And lastly, our tangent of alpha over 2 is equal to negative square root of 1 minus cosine of alpha, which is 12 over 13, over 1 plus cosine of alpha, which is 12 over 13. So that is the negative square root of 1 over 13 over 25 over 13, which is equal to the negative square root of, I'm going to multiply by the reciprocal, so 1 over 13 times 13 over 25, which is the negative square root of 1 over 25, or negative 1/5. And that is it for this section.